Our topic today is logarithm function. The inverse of an exponential function is called the logarithm function. Logarithm is another word for index, power, or exponent. Now, if we have b to be equal to a to the power x, where a is not equal to 1, and then the a is strictly greater than 0, then we say that now the power is the logarithm in base a of b. Mathematically, what do we mean? Mathematically, all that we are saying is that if that is b is equal to a to the power x, then we say that this if and only if, this symbol means if and only if x is equal to log a of b. And here the b2 is strictly greater than 0. So we know a2 is greater than 0, then a cannot also be equal to 1. B is also strictly greater than 0. So example, what do we mean by this? Now we know that 81 is the same as 3 to the power 4. So here we are saying that the 4, so this if and only if 4 is equal to log, what is the base? 3 of 81. And then we know if you're 1 over 7 all to the power negative 2. Now this is the same as 49. And we said this if and only if. Now the power here, that's the exponent, that's what we call the logarithm. So you see negative 2 is equal to, that is log, what is the base? The base is 1 over 7 of 49. Very easy, very trivial. So this is the definition of logarithm. We have to know that the base, the a, is strictly greater than 0, and it should not be equal to 1. B should also be greater than 0. Let's consider the following examples for better understanding. Now let's consider this example. Write the following in logarithm form. Now, what is the definition of logarithm? We know that if b is equal to a to the power x, this if and only if that is x is equal to log. Now, what is the base? The base is the base is a of b. Now, let's see the first one. We have 25 equal to 5 to the power 2. So here, the exponent, this is what we call the logarithm. So we say this, if and only if, so this symbol means this. If and only if, that is 2, is equal to log 5 of 25. Now let's see the second one. We have y to the power 4 equal to 3. So here, the exponent, this power here, is what we call logarithm. So this if and only if, that is 4 is equal to log. Now what is the base? The base is y of 3. Very easy, very trivial, and interesting as well. Now if you have 3 to the power negative 2, this equal to 1 over 9. So the index is what we call the logarithm. So this if and only if, that is negative 2, is equal to log, what is the base? 3 of 1 over 9. Very easy, very trivial. Let's consider the next example. Now let's consider this example. Say that find the value of the following. The first one, log 4 of 16. So this, we can say that 1, that is log 4 of 16 to be equal to x. Now from the definition of logarithm, so this one, if and only if, that is 16 is equal to 4 to the power x. Now here we have 16, we have equal to 4 to the power x. Now can we make the bases the same? Yes, we can make the bases the same. So we have 4 to the power 2 equal to 4 to the power x. We learned from indices that if you have a to the power m equal to a to the power n, then we can say m is equal to n. The bases are the same, so we say therefore the exponent must be the same. Now let's see the second one. We can say that let log, that is 1 over 32 should be equal to x. So this, if and only if, that is 1 over 32 is equal to, that is 2 to the power x. Now let's make the base the same. We can rewrite this as 1 over 2 to the power 5, which is equal to 2 to the power x. And this is the same as 2 to the power negative 5, which is equal to 2 to the power x. Why this? Why? We know if you have a to the power negative n is 1 over a n. So if your 1 over a n is equal to a to the power negative 5. Clearly equating the exponent, you have x to be equal to negative 5. Now let's see the fourth, no, that is the third question. So with the third question, we can say that that is we have log 1 over 3, 9 should be equal to x. And this implies that we can say that 9 is equal to, that is 1 over 3 or to the power x. Here, let's make the bases the same. So here, this is just 3 to the power 2 equal to 3 to the power negative 1. We have x. Why are we saying that? We know that if we have log ab equal to c, then we can say b to be equal to what? A to the power c. So here our b here is 9. Our b here is 9, and then our a is 1 over 3. Or from our own definition that we use, we know that if b is equal to a to the power x, then we can say x is equal to what? That is log a of b. So if you have this, we can transform it to that. Now we know from indices, if you have a to the power m, all n is what? A m n. So clearly we have 3 to the power 2 equal to 3 to the power negative x. While this time that's negative x. Bases are the same, so the powers 2 must also be the same. So we have 2 to be equal to negative x. Therefore we have x is just equal to negative 2. Very easy, very trivial. Let's see the fourth one. We have log 5 of 1 to be equal to x. So let this one to be equal to x. Clearly 1 is equal to 5 to the power x. We have to make the bases the same, because if you know, if you have a to the power m equal to a to the power n, then we say that m is equal to n. Now we have 1 here, this is 5, so we change this to 5 to the power 0. So 5 to the power 0 equal to 5 to the power x, which implies that x is equal to 0. Now let's see the fifth question. Let's see the fifth question. Now with the fifth question, we have, that is log 6, and this should be equal to x. Let this one to be equal to x. So from the definition of logarithm, we know that 6 is equal to 6 to the power x. Clearly we know this is to the power 1. So because the bases are the same, hence the exponent are the same. Very easy, very trivial. Don't forget to get a copy of the books that you're seeing on the screen to give you a firm foundation in math. Now let's consider this example. Find the value of the following. The first one, log 1 over 2 of 8. So our first one, so here we can say that that is log half of 8 to be equal to x. Now from our definition of logarithm, clearly here 8 is equal to half to the power x. Now why are we saying this? We are saying that if you have b is equal to a to the power x if and only if x is equal to log a of b. So clearly you can see that a is going to we are going to have b to equal to a to the power x. That's what we have here. That is 8 is equal to half to the power x. So from here, we can have that. Now here, this is an exponential equation, so let's make the bases the same. 8, we can express it as 2 to the power 3. And this is 1 over 2. This is the same as 2 to the power, that is -1. And then we have x. Why are you saying that? Because if you have a to the power -n, this is 1 over a n. This is a principle that we use on this, which gives us that. So clearly we have 2 to the power 3 equal to 2 to the power, that is -x. So clearly, what can we see? 3 is equal to -x. Therefore, our x is just equal to -3. Now let's see our second question. Our second question, you can say that that is log 4/8 root 2 should be equal to x. Now, from here, from our definition of logarithm, clearly 8 root 2 is equal to 4 to the power x. Now, this is the same as 2 to the power 3 times, now, root 2 is the same as 2 to the power 1 over 2, which is the same as 2 to the power 1 over 2. That is 4 is the same as 2 to the power 2, so you have 2 to the power, that is x. What do you know? When the bases are the same, you are multiplying, you add the exponents. Here 2, 3 plus 1 over 2 equal to 2 to the power 2x. The bases are the same, so we equate the exponents. We have 3 plus 1 over 2 equal to 2x. What is the LCM? LCM is 2, so that is 2 times 3 plus 2 times 1 over 2 equal to 2 times 2x. Clearly, this is cancelling that 6. We have 6 here plus 1 equal to 4x. What is 6 plus 1? We have 7 equal to 4x. Therefore, x is equal to 7 over 4. Now, how many times will 4 go into 7? That will be 1. So you have 1 over 3 over 4. Now, let's see the third question. The third question, so you can say that that is log 8 root 2 should be equal to x. Now, from our definition of logarithm, what do you have? That is 2 root 2 equal to 8 to the power x. Now, this is the same as 2 to the power 1 times 2 to the power 1 over 2 equal to, that is 2 to the power 3 or 2 the power x. So we know indices, when the bases are the same and you're multiplying, we add the exponent. So this is just, that is 2 to the power 1 plus 1 over 2 equal to 2 to the power 3 x. From the laws of indices, we know that if you have, that is a to the power m times a to the power n, this is what a m plus n. And we know if you have a to the power m all to the power n, this is a m n. Very easy, very trivial. So here the bases are the same. Exponential equations, we equate the exponent. That is, if you have a to the power m equal to a to the power, and because the bases are the same, we say that this implies m is equal to n. So hence we have 1 plus 1 over 2 equal to 3x. Bases are the same. We equate the exponent. Now, what is the LCM? LCM is 2, so we have 2 times 1 plus 2 times 1 over 2 equal to 2 times, that is 3x. Now this is cancelling out that, so 2 plus 1 equal to, that is 6x. 2 plus 1, we have 3 equal to 6x, so we have 3 over 6 equal to 6x over 6. This is cancelling, this will get 1, this will go here. 2, so we have our x is just equal to 1 over 2. Very easy, very trivial. Let's see the fourth question. So let's log 0.258 equal to x. Now, from our laws of, that is from the definition of logarithm, clearly 8 is equal to 0.25 or to the power x. Why are we saying that? We are saying that if you have b equal to a to the power x, then we see that this if and only if x is equal to log a b. So if you have this, then we say we can have that. So clearly, let's see here, what is our a? Our a here is 0.25. And then what is our b? Our b is 8. So from here, we have to make the bases the same. Our exponential equations. So here, 2 to the power 3. Now, 0.25 is the same as 1 over 4. And this all to the power x. So let's say we have 2 to the power 3. Now, 1 over 4 is the same as what? 1 over 2 to the power 2. And then we have x here. Making the base the same, we have 2 to the power 3 equal to 2 to the power negative 2. And then we have x, we have 2 to the power 3 equal to 2 to the power negative 2x. Why? If you have a to the power m all to the power n, this is what a m, and you multiply the m and then the n, so you multiply negative 2 times x, we have that. Now the bases are the same. What do? We equate the exponents. We have 3 equal to negative 2x, hence x is negative 3 all over 2, and this is just, that's negative 1 whole number 1 all over 2. Very easy, very trivial. Let's consider the fifth one. So we can see that that is log, we have 2 root 2 all to the power 6. We say this should just be equal to x. So from our definition, clearly this is the same as what? Root 2 to the power 6 equal to 2 to the power x. Now this is the same as 2 to the power 1 over 2, 6 equal to 2 to the power x. Now what do we know? If you have a to the power m, and then this is equal to a m times n. So here we have half times 6 equal to 2 to the power x. 2 go here, 1, 2 go here, 3. So you have 2 to the power 3 equal to 2 to the power x. The bases are the same, so the exponent too must be the same. How was it like? Very easy, very trivial, and then very, very easy to understand as well. Let's consider the next example. Now let's consider the laws of logarithm. So let's say when we let p to be equal to a to the power m, then what can we say? You can say that then m is equal to log a p. And then also when you let that is q to be equal to a to the power n, then we can say n is equal to log a q. Why are we saying this? From our definition, you know, if p is equal to a to the power x, then we see x, we see if and only if, that is x is equal to log a of b. This is what we are using over here. Now, hence, let's get to the first law. Now, if we have p times q, now this what? That is a to the power m times a to the power n. When the bases are the same, what do? We add the exponent. So we have what? That is a m plus n. So we have our pq to be equal to a to the power m plus n. Now clearly from our definition of logarithm, clearly we can say what is the m? M plus n. Clearly we can say what? M plus n. This is equal to log a of, that is pq from our definition. That is, if we have p to be equal to am, then we can say m is equal to what? Log ap. And here, if you have b to be equal to a to the power x, clearly x is equal to what? Log a of b. Hence, if you have, that is pq equal to a to the power m plus 1, then the logarithm, that is m plus 1 is equal to log of the base a of pq. Now, what is our m? What is our m? Our m is log a of p. So log a of p. And what is our n? Our n is, that is log a of q, and this is equal to log A P Q. This is our first law. Very easy, very trivial. So if you have log A of P plus log A of Q, this is equal to log A P times Q. It's telling us when the bases are the same, we are adding, then we subtract. Then it is telling us when the bases are the same and we are adding, then we can multiply. Then an example, let's consider some example here. If you have log 2 of 5 plus log 2 of 7. So here let's say the bases are the same. And this is equal to log 2 of P Q. So clearly here, this is what? Log 2. Our 2 is our A. So log 2, and then we have what? 5 times 7. And this is equal to log 2 of 35. Let's consider another example. If we have log 3, that is root 7, plus log 3, another root 7. Clearly we are adding. What do? We multiply them. So we have log 3, we have root 7 times root 7, and it's just the same as log 3 of 7. Very, very easy. So the first law says if you have log A of P plus log A of Q, this is equal to log A P times Q. Now let's consider the second law. So for our second law, if you have, that is P divided by Q. Now what is our P? Our P is A to the power M. What is our Q? Our Q is A to the power N. Now you know when the bases are the same and we are dividing, we subtract the exponent. So we have P over Q to be equal to A M minus N. And from our definition of logarithm, clearly M minus N is equal to log A. We have P over Q. Now what is our M? Our M is the same as, that is log A of P, minus, what is our N? Our N is just the same as log A of Q, and this is equal to log A P over Q. So what the second law is saying is that when you are subtracting, the bases are the same, we divide. So log A of P minus log A of Q, this is equal to log A P over Q. Let's consider an example. If you have log 2 of 10 minus log 2 of 5, the bases are the same, you are subtracting. So this is just the same as log 2. We have 10 over 5, and this is just the same as log 2. 5 will go into 10, that is 2 times, and this is just equal to 1. Now let's see the third law. Now we know that now if you have P to the power N, but then what is our P? We knew our P to be A to the power M. So here that is A to the power M or N. Initially we said P is equal to A to the power M. So if you have P to the power N, then you have A to the power M all to the power N. And this is just equal to, that is A M N. From index, loss of indices, M will multiply the N. Hence from, that is definition of logarithm, clearly Mn equal to log A of P to the power N. Now this is the same as, we know multiplication is commutative, so this is the same as what? Nm, which is equal to log A P of N. Now what is M? We know that M, earlier on, what did we get M for? M is equal to log A of P, log A of P. So from here, our M is equal to log A of P. So N, our M is just log A of P, and this is equal to log A P of N. So you have N log A P equal to log A P of N. So this is our third law. So all that is saying is that if you have log, let's say 5, 7 of 3, then this is just the same as 3 log 5 of 7. And then also if you have log, that is 8, 5 of 4, then this is the same as 4 log 8 of 5. Very easy, very trivial. Now let's consider this example. It says that express in terms of log ax, log ay, and log az. So we want to express in terms of that. Here, clearly, there's no xy here. So separately, ax and then ay. Now let's see the first one. That is I. You have log ax, y. So clearly, we know from the laws of logarithm, when you're multiplying, then we add. So here, this is the same as that's log a of x plus log a of y. Why? We know that if we have, that is log apq, this is the same as log ap plus log aq. So when you're adding, what do you do? We multiply. So when you multiply here, that's just adding. So now the second one, we have log e, we have x, y, z. That is x, y, z. Clearly, this is what we are multiplying. So this is just the same as log e of x, multiplication, plus log e of y, plus that's log e of z. So when you are multiplying, if you have log apq, the same as log ap plus log aq. So here we are multiplying x, y, z. So we have log a of x plus log a of y plus log a of z. Now let's see the third one. We have log a, and we have x over y. We want to express in terms of, that's log a of x and then log a of y. So clearly we are dividing, so we subtract. So this is the same as log a of x minus log a of y. So when we are dividing, what do? We subtract. Very easy, very trivial. Now let's see the fourth one. The fourth one, we have log a, we have xy over z. Clearly we are dividing. So here, this is the same as log axy minus log a, that is z. Well, if you have log a p over q is equal to log a of p minus log a of q. So that's what we have here. But then you can see that here we have xy. What we are being told to express in, there's no xy here, but we have log a of x and then log a of y. Now this is multiplying this. So this is the same as log a x plus log a y. This we reduce to this minus log a of z. Now let's see the fifth question. The fifth question, that is, we have log a, and then we have, that is, x over y z. So from the second law, this is the same as, that is, log a x minus log a y z. Why? When we are subtracting, what do? We divide. So clearly, let's see, but then here we have yz. There's no yz in it. We are supposed to express in terms of log ax, log ay, and log a z. So this multiplying, we have to reduce this. We have, that is, log ax. But we shouldn't forget the negative is affecting everything inside. So this is the same as, that is, log ay plus log az. Now this negative is affecting everything here. So this is the same as, that is, log ax minus log ay minus log az. Now let's see the sixth question. Let's see the sixth question. The sixth question, we have log a x squared y, and this multiplying. So this is the same as log a x squared plus log a y. Now x squared, we know if you have log ap n, this is the same as n log AP. So this is the same as, that is 2 log A x plus log A y. From the third law, we know that if you have as log A P, and this is the same as what n log A P. That is from the third law. Now let's see the seventh question. Now we have log A, we have x root y, x root y. Now this is multiplying, this is the same as, that is log A x times root y, and this is the same as, that is log A x plus log A root y. Now this is of the third law, so we have this is the same as, that's log A x plus, that's log A y to the power 1 over 2. So using the third law, this will come here. So this is the same as, that is log A x plus 1 over 2 log A y from the third law. Very easy, very trivial. Now I have rather interchanged it. What I've done rather is this eighth question. That is the eighth. This should be rather the eighth question. So the seventh question. What is the seventh question? Rather, our seventh question is log A. We have y over, that is z square. So log A, and then we have y over z square. And this, applying the rule, that's the law log A of y minus log A of z square. Why? When you are dividing, we subtract the exponent. And applying the third law here, this is the same as, that's log AY minus 2 log AZ. Now let's see, so we've done the eighth one, the ninth one, that is IX. With IX we have log A, and then we have, that is x squared z to the power 3 all over, it should be all over y, it should be over y, it should be over y. So all over y, all over y. Now you know that when you're dividing, what do? We subtract. So this is the same as, that is log A of the numerator, that is x squared z cubed minus log A of y. Now what can we see here? This is multiplication, same base. So this is the same as log A x squared plus log A z cubed minus log A, that is log A y. Now applying the third law over here, the 2 will come down, the 3 will also come down. It's the same as 2 log ax plus log a z. That's the 3 will come down, so you have 3 log az minus log a y. The third law, if you have log a p, and this is the same as n log a p. Okay, let's see the last one. That is the x, the 10th one. This is the same as log a x to the power n y to the power m. So x is multiplying y. So this is the same as, that is log a x to the power n plus log a y to the power m. We know if we have that log a p, and this is the same as n log a p, hence this is just equal to n log ax, that's the third law, plus m log a y. Very easy, very trivial. Get a copy of the books that you are seeing on the screen. It will give you a very good foundation in math. We have solved a lot of questions on the video tutorial which we have attached to the books. Call the numbers right now for a copy for yourself. Now let's consider the following examples. Express the following in terms of log x, log y, and then log z. So let's see, first one, that's I. We have log that is x squared y to the power 5 all over z to the power 6. Now, when we don't write the base, it means the base is 10. So this is just equal to, that is log, the base is 10, so this we have x squared y to the power 5 minus log z to the power 6. We know if you have log a p over q, this is equal to log a of p minus log a of q. So we are dividing, so we subtract. Now what can we say? This and this are multiplying. So this is the same as what? Log x squared plus log y to the power 5 minus log z to the power 6. Now what does the question say? The question we should express in terms of log y. But here we can see log x to the power 2 log y to the power 5 log z to the power 6. But we want only log x, log y, and then log z. So here let's apply the third law. Now, so from the third law, this will be 2 log x plus 5 log y minus 6 log z. You know that the 2 will come down, the 5 will come down, and then the 6 would also come down. Now here it's in terms of log x, log y, and then log z. Why? We know that if you have log a p to the power, and this is just n log a p. Now let's see the second question. We have x root y all over, that is z to the power 1 over 3. And this is just equal to log x root y minus log z to the power 1 over 3. If you have log a of p plus log a of q, what do you know? When you're adding, we multiply, and then when we are subtracting, we divide. So in this case, because we are dividing, we will subtract. Now this is multiplying this, and then this is just the same as log x plus log root y minus log z to the power 1 over 3. So this is the same as we have log x plus log y to the power 1 over 2 minus log z to the power 1 over 3. Now applying the third law, this is the same as that's log x plus 1 over 2 log y minus 1 over 3 log z. That is applying the third law. The n will come down here. Now let's see the third question. Let's see the third question. The third question we have log cube root of, that is x squared y all over z to the power 4. Now, and this is just the same as, that is log, that is we have x squared y all over z to the power 4 all to the power 1 over 3. And this is just other form, that's log a p n, which is the same as n log a p. So in this case, our n is 1 over 3. So this can just come down, so you have 1 over 3. Let's bring a bigger bracket, multiplying everything. So we have log, that is x squared y all over z to the power 4. And this is just equal to, we have 1 over 3. Now we are dividing, so first let's subtract. So we have log, that is x squared y minus log z to the power 4. Why are we saying this? Clearly we know that if you have, that is log a p over q, this is the same as what? Log a p minus log a q. So that is what we are applying here. Now let's see this side, we are multiplying. So when you're multiplying, we add. So you have 1 over 3 out. We have log x squared plus log y squared log y minus log z to the power 4. Now applying the third law, clearly this will come down here, and then the 4 2 will come down here. So you have 1 over 3 2 log x plus log y minus 4 log z. Now if you like, we can let the 1 over 3 be here, or we can multiply through the 1 over 3. So this is the same as, that's 2 over 3 log x plus 1 over 3 log y, multiplying through with 1 over 3 minus 4 over 3 log z. Now either we use this method or let's see, that is we have log x squared y all over z to the power 4 all to the power 1 over 3. Now from indices, we know if you have a over b all to the power n, this is the same as a n b n. So this is the same as this log, we have x squared y all to the power 1 over 3 all over z to the power 4, we have 1 over 3. Now, and this, we know that if we have, that is a b all to the power n, this is just a n b n. So we apply that method over here. So this is the same as log, we have x to the power 2 times 1 over 3, we have y to the power 1 over 3 all over z to the power 4 over 3. Now, what is this? We have the up one over the down one. So clearly this is the same as, that is log of the up one. We have log 2 over 3 y 1 over 3 minus log, we have z to the power 4 over 3. Why minus? We know if we have log a of p minus log a of q, this is the same as log ap of q. So if you have log ap over q, we can express as what? Log a of p minus log a of q. So when you're dividing, we subtract. Now this multiplications, we have log x to the power 2 over 3 plus log y to the power 1 over 3 minus log z to the power 4 over 3. 4 over 3. Now the 2 over 3, 1 over 3, it can come down, 4 over 3 can come down using from the third law. So this is the same as 2 over 3 log x plus 1 over 3 log y minus 4 over 3 log z. So that's it, and clearly this is the same as that. Very easy, very trivial. Don't forget to call the numbers you are seeing on the screen now for a copy of the books for yourself.